So let's look at question 5 from chapter 8. And it asks about the NAEP test and gives you some information about what that test is. And then it says, suppose you give this test to an SRS of 840 people. So we have an SRS where N is 840. And the mean of this is 280. The true mean is 280. And the standard deviation, it tells me, is 60. Now we know this is a very large sample size, so I can use the central limit theorem to decide that the distribution is going to be normal. So part A says describe the shape, center, and spread of the sampling distribution of X bar. So this is the X bars when N is 840. Well, I know it's going to be approximately normal. I know that the center will be at 280, and I know that the standard deviation of my sampling distribution is going to be the standard deviation of the population divided by the square root of N. So in this case, that's 60 over the square root of 840. 840, and that works out, if you do the math, to be about 2.0702. So I'll write 2.07. So there's the center, shape, and spread of the sampling distribution. Now B says sketch the sampling distribution, mark the mean, which I've done, and then make marks at 1, 2, and 3 standard deviations from the middle. So when I count out by 2.07, then I end up 1 standard deviation away, which is 277.9 and 282.1, basically 282.1, and then I can count out another standard deviation, and I'll do those in a different color so you can see it, and that would be 275.8, and this would be 284.2. And then counting out yet one more standard deviation. It's kind of getting messy here on this, but that's going to be 273.7 and 286.3. And all I'm really doing here is, I know that standard deviation is this, so each of these widths right here is 2.07. And I'm just counting by intervals of 2.07 as I go along. And so part C says 95% of the values will be within M of the mean. Well, that's 2 standard deviations. So for part C, M, since we're going with 95%, M is 2 of these standard deviations. So it's 2 of these 2.07s. So it's about 4.2 or 4.14 something, depending how you round. And finally, oh, and it tells me to mark that on here. So that's this. That's 2 standard deviations, which accounts for 95%. And finally, I'll change this to 2.14. And finally, whenever D, or for part D, whenever X bar falls in the region you shaded, the population mean lies in the interval X bar plus or minus M. For what percent of all possible samples does the interval capture mu? Well, based on, so we'll say based on the 68, 95, 99, 7 rule, it's about 95%. And so that's basically the idea of what we're looking at on problem 5.